So thanks a lot for coming. My name is Ara Pulido. I'm engineering manager at Bitnami. This is actually my second KubeCon, so I'm still pretty new to the community. And for the next few minutes, I'm going to be talking about a tool that we discovered in the previous KubeCon in Austin, and since then has become a key piece of our development process. So first of all, who we are. So Bitnami is a leader in application packaging. We have more than 120 applications on the cloud marketplaces, like AWS, Azure, GCP, etc. And that's how a lot of people know us. And a couple of years ago, we started investing a lot in containers and Kubernetes. And with the application packaging in our DNA, we invested a lot in Helm. And we actually continue maintaining more than 20 of the official charts there. But we also do a bunch of open source projects that are always on the application deployment area of Kubernetes. So we have Cublas, which is a serverless framework for Kubernetes. Cublas, which is an application dashboard for Kubernetes for your cluster, which is actually the application that we use Telepresence for. And others like seal secrets or QCFG that we develop with Heptio, seal secrets, and others. And since we started investing a lot in Kubernetes, we also did that internally. So we run many of our workloads in our Kubernetes cluster, and we love Kubernetes as a production environment for your containerized applications. But it seems like the development process for it was like a little bit of an afterthought. And it's really, when you're developing full Kubernetes, suddenly it becomes very, very difficult to manage. So just to put an example of a very, very simple cloud-native application, very quickly it becomes this microservice architecture where you may have different ingresses rules that redirect traffic to a front end, maybe a web UI, and that web UI may talk to one or different services on the back end, and those services may talk to each other, and they may need to talk to, for example, an external database or another external service that may not be in your cluster. So even with a very, very simple app, it suddenly becomes this difficult mess to handle on the development process. So how we've been doing that historically is basically replicating our architecture in production in a Docker Compose and making these little tricks that we all do, like we may have a config map in Kubernetes, and we may replace that with just a volume mount on Docker Compose, and we may replace our secrets with just an env variable. And we may have several services described there for service discovery, and we may have our volumes, et cetera, et cetera. And as the application grows, you have to keep maintaining those two manifests. So the manifests that you run in production, the ones that you use in Docker Compose to develop, and they may diverge, and then you may find regression, so things do not work exactly as you expected when you go to your cluster. And also there are things that are not that easily described on a Docker Compose, like your Ingress rules, or jobs and cron jobs, or your init containers, or your RBAC rules, and your kubeconfig, et cetera, et cetera. So then there is the second solution, is having this development cycle of you build your image, you make a change, you build your image, you push it somewhere to a registry, hopefully on your cluster, maybe somewhere else. You change your manifest, or maybe your manifests are pointing to a dev image directly, so you test your changes, doesn't work, and you do that over and over again. And this can become very, very slow. You can be doing things like making sure that you're building your image as part of your build process to accelerate things. But again, it's always a little bit slow. And even if you have to push somewhere in the registry, you may have these issues of making it a little bit more slow. So obviously, this is a problem that a lot of people are thinking of. And there are several solutions that are there. And as I said, we discovered Telepresence last KubeCon. It's a tool by a company called DataWire. And very, very high level, what it does is allows you to run a process that is fully connected to a cluster. And that cluster could be on your local environment with Minikube, but it also, and ideally, will be elsewhere in the cloud. So you can have all the compute that you need, all the memory that you need to run the different services that you're not actually debugging, you're not actually developing, but your application may need to talk to. So how it works is Telepresence will deploy a two-way proxy into your cluster that start proxying data from your cluster to a client running on your local machine and back. Basically what it gives you, you get service discovery with full DNS resolution from your local machine, so you can talk to any of the services that are in your cluster in a seamless way. You have volumes, you have environmental variables, so all the things that you may need from your cluster when you're developing a service that you're planning to put on that cluster directly from your local machine. And I think the key thing and the thing that we like about Telepresence is that it does that without you even almost noticing. So you run a local process, and it's talking to everything on your cluster without you having to do any change on the code because it's using the same service discovery, volumes, environmental variables, etc. Telepresence has several proxying methods. Each of those has pros and cons. You can use the one that you think is going to serve you better. The first one is VPN, where it creates basically a SSH tunnel between the proxy running in your cluster and the client, creating more or less like a VPN. The only downside is that you cannot use another VPN on top. And actually, I was testing the demo the other day, and I was freaking because it wasn't working. It was because I was actually running on my company VPN. Then you have inject TCP, which basically injects a shared library into the process that you want to run, and with a clear limitation that it doesn't work with statically linked processes, like Go. And then Docker, which is very similar to the VPN process, with the difference that instead of running just a process, it allows you to run an image that you already built, which works well if you already have this container native development process where your build process is not building your app, it's building your app and building a Docker image. So the idea of this talk, more than talking about, is to show you how it feels using Telepresence. So I've prepared a couple of demos. And let's see. I'm going to explain the first one. Is this big enough, or maybe bigger? Better? Okay. So the first one is very simple. It's just to show you all these service discovery, volumes, etc. that you can have. So we have this couple of pods in a cluster. By the way, I'm running this on Minikube just to avoid using networking too much. Yes, the idea is that you would have a development cluster in the cloud or in your servers in premise to do this. We have this service, a very simple service called QOTM. The only thing it does is it's listening on port 5000, and when when you make a request, it returns a JSON with a random code. It's just as simple as that. We use it as an example of a service that may be running on your cluster. It's not the one that you're developing, but you need to talk to it as part of your application. And then we have this telepresence test that, let's check what it is. It's part of a deployment. It has an init container, so you can see that we can still use init containers. The only thing that it does is mounting the volume called data into a mount path /data, and just creates just a simple random string on a file. And then we have our main container, which has here an environmental variable. It's not a real secret in this case, but it could be a key ref to a real secret. It will still work. And then you have the same volume mount, and basically it reads the file that it was supposed to be created by the init container. And the volume is just a simple empty there. So obviously, if we check the logs of that pod, we have random data there, as we expected. And now let's imagine that there is something not going okay. We didn't get random data there. There's something going wrong. We may think that it's something with the volumes, something with the init container. We want to debug a little bit. So basically, we are going to tell Telepresence to swap the deployment called Telepresence test. And let's watch here the pods as well. But I'm not telling Telepresence to run any process on top, so what it's going to do is to start a bash session that is already connected to my cluster. So as you can see, what is happening is it's swapping the deployment, and we will see when it finishes what it's actually doing. So, and obviously swapping is changing the deployment, and the deployment controller, the Replica controller, is doing its thing. And basically, some things that it says here. So it says that it's starting the VPN method. That's the default one, so that's the one that it's going to use if you don't tell it otherwise. And then it says volumes are routed at Telepresence root. And it says that no traffic is being forwarded from the deployment to my pod. We will see on the second demo how to use that. And so let's check. So one of the pods is terminating, the other one is starting. So let's check how this pod looks like. So you can see we have the volumes there. We have our init container still here. And we have the main container with our environmental variable, some special variables coming from Telepresence. And as you can see, the image has changed from the BusyBox image that I was using to the Telepresence proxy image. So back to the shell that is connected to my cluster. So let's check first volumes. So volumes are routed at Telepresence root, so let's go there. So we can see that the data volume was correctly mounted. And if we check the data there, our init container created that file correctly. So we can see that way, we can have access to the volume and see if something was wrong there. Also, we have several environmental variables. Some of them are coming from my local machine, so is coming from my local machine. But also, I have access to the ones that are on my pod. This is the one that it was on the pod description, and it's still there. So I can have access to any of the environmental variables there. And lastly, we have, remember that we were running this service on port 5000 called QOTM that basically return a JSON with a random code. So directly from here, from my local machine, I can call QOTM on, and I can use the same DNS service discovery in Kubernetes. So if it's running on a different namespace that I have access to, I could use dot namespace, et cetera, to get access to it. As you can see, it works. It feels like I'm executing into a container inside my cluster, but actually I'm not. As you can see, it's still running. So if I go here, is my local machine. So this, if I exit here, it's going to do the opposite. So it's going to replace back the container by the original one, and leaving my cluster as it was before I started Telepresence. So this is a very simple demo, but it already shows what you can do with Telepresence if you need. And I'm going to show now how we are using it to develop Cublas, which is an application dashboard for your Kubernetes cluster. So Cublas comes with a CLI. I'm going to make that bigger. So it comes with a CLI tool. If you do Cublas app, it will deploy all the different components that are part of Cublas into your cluster. And you can see that there are different deployments. Also one in the Cublas namespace. So the one that we are going to use Telepresence for is Cublas dashboard UI. What is this UI? So if we run Cublas dashboard, it's going to start this application dashboard. What you can do with it, you have access to your Helm deployments. We are using actually not only using Tila directly, but using something we call Helm CRD, which for every deployment creates a CRD object, and there is a controller looking after it. We have a set of charts available on different repos. You can add repositories if you need to. And this sync, for example, is happening also with a different deployment, a different CRD. Functions through Cublas, so we have function as a service in Cublas with Cublas integration, so you can have any function that you may run here. Each of these functions in Cublas is, again, a CRD called function. And then also it has service catalog integration. Service catalog is an API extension for Kubernetes that allows you to connect external services provided by what is called a service broker into your cluster. And this, again, is an extension of the API. So you can see this UI has a lot of knowledge about your Kubernetes cluster, and it would be very, very difficult to just trying to develop this UI locally. So what we are going to do is we are going to tell Telepresence to swap the deployment called Cublas dashboard UI, which is the UI that we just saw, on the namespace Cublas, because it's not running on the default namespace. We are using, in this case, the inject TCP method, although there are people on our development team that are using VPN as well, so both work well. And also we are telling it to redirect all the traffic on the cluster on port 8080 on that pod to port 3000 on the local port. And the reason why we are doing that is because we are then going to run a development server for that application that is running on port 3000 by default. So again, it's starting the proxy, this time with the inject TCP. It's warning you about some limitations of that. Same thing, volumes are routed to a Telepresence route, and it's forwarding traffic from port 8080 to 3000. So let's run a development server on port 3000. It's going to take some seconds to start. So it says now that it's listening on localhost 3000, but instead we are going just to access through this proxy to our cluster that we just created. And actually, now that it refreshes, this UI is actually running on my local machine through port 3000. So, and I still have access to all the service catalog classes that I have for this particular broker, functions, the charts, applications, etc. So to demonstrate that that's true, we are going to do a quick live change. So this particular file is rendering the view here, the applications. So this header, H1 header, is that same header that we saw. And we are just going to save that. And our development server is going to realize there has been a change, and it's going to reload the page, and it's showing the change. So that way, it allows us to do a lot faster development process for this particular application. And since we've started using Telepresence, it has been a lot easier to make these changes while making sure that we were able to keep those services running on a cluster, talking to our local service. So that's it for the demo. The only thing left for this talk, I'm going to ask Richard Lee, who is the CEO of DataWire. Thanks for coming, Richard.
Hi.
Applause for him. And he's going to be talking a little bit about the plans that they have for Telepresence for the next few months. Should work.
Does this work? Okay. Yeah, so thank you for the great demo. So what we're working on, so Telepresence is all open source. We're actually taking it through the CNCF sandbox process right now from a sort of governance and open sourcing perspective. From a development perspective, we're focused a lot around robustness and speed. One of our use cases we like to talk about is the Caltrain use case. So if you've been to Silicon Valley, a lot of developers take Caltrain from South Bay up into the valley, and there are bad spots for Wi-Fi, and so you can't do Reconnect with Telepresence right now. So we want to support things like Reconnect and better performance on behavior when you have bad network connections, improving startup speed. We've done a lot of work around cleaning up. You saw from the demo how we actually swap out the deployment and put in a proxy. And there were certain situations where we would leave that proxy hanging out in the cluster. We want that behavior to improve. So we've done a lot of work around robustness. We're doing more deployments at larger organizations that do have a lot of RBAC controls in place. So we've been going through and auditing the permissions that Telepresence needs, so you need to actually use it. We're also looking at transitioning away from inject TCP because it requires hacking LD preload or DINlib on your laptop, which is actually very difficult from a maintenance perspective. So we are actually exploring other strategies so you can actually support running telepresence even though you have a VPN client. So, and then we're also looking at some more future-looking use cases around things like traffic shadowing, copying production traffic or a percentage of production traffic to your local laptop for production testing, simplifying the UX so you can actually have a config file for configuring it. A lot of people are asking us around how do I configure this with build system X, like they want to run it automatically for part of Gradle or use it with particular IDEs, and how do you copy environment variables from my local process into my IntelliJ IDE. So we're trying to do a little bit of work around that, and also supporting Istio. So some users have actually manually integrated telepresence with Istio so that you can actually authenticate to your main website, foo.com, and through the magic of Istio routing rules, actually route those requests straight down to your laptop so you can actually do real-time development versus your production system. So those are some of the things that we're looking at, and we're also really interested in just general feedback around use cases and how people like to use telepresence, because it's very dependent on your developer workflow, and we find that everyone has their own sort of way of doing things. So.
Cool. Thanks. Thank you.
Thank you.
If anyone has any questions, yeah.
Hi, hello. So perhaps how would I go about allowing multiple developers to develop against the same set of backend services running on our cluster, so that they could work concurrently?
I don't think there is a way right now. So that proxy, so the telepresence client would talk to a proxy at one of the clients to the proxy. So it won't allow to talk to several ones. Maybe Richard.
Sorry. Yeah. So you can't do it right now. So mostly what people do is they create their own namespaces or clusters for each developer. We are working on some other techniques that let you at least detect when you actually have collisions when you run on the same namespace. But yes, it's a great question.
So I'm going to repeat the answer for the recording. So there is no way right now to do that. The workaround people do is to put different namespaces per developer, so you can run the rest of the services together.
Just to make sure that I understood it correctly, the only usage currently is for static files changes, or does it also include like applications that are developed, let's say, with a compiler or something, like Java-based applications or something like that? I mean, your demo just covered a static case for changing some HTML, but what happens, for example, when I have like a Java-based application?
Yeah, you can change your JavaScript, so it's not for static files. So it's basically anything that you're running on your local process would be the one that is talking to the proxy. So it could be any application. It could be a Go application.
Okay, thanks.
So I was curious, how are you authenticating to the cluster, and what permissions you use in order to run this telepresence?
So it's basically using your kubecfg, so your kube config.
Hello. First of all, what is the protocol used to stream the files from your local machine to the remote machine?
I think that would be a better question maybe for Richard, who know more about the internals.
Yeah, so we're just using essentially SSHFS for your file system, and we're using, I forget what it's called, but it's an SSH-based VPN for the VPN method. So it's all sort of layer 4 networking type stuff is how we're actually, you're basically doing a layer 4 proxy between the cluster and your laptop.
And my second question is on the solutions for proxying the traffic. Have you thought about using SSH Proxy that would allow delegating DNS resolution of the local application to the remote cluster?
Yes, that's what we do. We actually use a fork of TorSox.
And
when you create the connection to your laptop and you have your process running and then you close your laptop and go home for the day, does the Telepresence quit and revert back to the original process?
yeah, basically it closes the connection and goes back to. It's one of the what he said that they're working on actually being able to reconnect. But yeah, it basically goes back to how it was.
Yeah, so when the connection's dropped, when you terminate the Telepresence proxy on your laptop, it actually will clean up itself in the cluster. However, if you go to sleep, the behavior isn't super nice, and that's one of the things that we're actually working on. And sort of we're architecturally exploring the idea of a persistent proxy on the cluster that you can actually reconnect to. Because right now we deploy the proxy every time you invoke the command.
So how many developers are working simultaneously at Bitnami on the same project, on same cluster right now, and how happy they are with Telepresence? Can you
repeat the question?
So
sorry?
how many developers are currently working on the same project or same cluster using Telepresence in your project right now?
So right now it's mostly 3 people, but some people are using different clusters, so it's not. And some of them are using Minikube as well during the development, so it's not, we are not using concurrent access of the same cluster.
So it's easy to see how you could fall into some development practices that are unfortunate if the way you're editing your code starts to diverge from what actually goes into the images that are built.
Yep.
Can you share something about your experiences and best practices there?
Yeah. So actually, that one of the things that ideally you would move to is the container native, where you build processes. You building an image, you build the Docker image, and then you use the Docker method with Telepresence. Allows you to run that new image, and you make sure while still be able to make changes, so you can still do tricks for faster development, like mounting your development folder into that image while you run it. So you pass any Docker run parameters that you want. So you can still do tricks to go faster, but at the same time, you make sure that you're building an image and it's similar as possible when you would run in production.
Have you identified any use cases for using Telepresence for more than just development, maybe for CI or for creating a sandbox environment?
So right now we are just using it for this project. We just started using like 2 months ago. We haven't been thinking about other use cases. There is a question over there.
Sorry, another question. So it works fine if you've got 1 instance of your container. What happens if you've got 10 instances of your container in your cluster and you're trying to Telepresence from your machine?
Yeah, so depending, so what do you mean? Like you have several deployments?
So you've got 1 deployment?
Yes.
Several pods, right? So you've got 10 pods. Then your Telepresence, you use Telepresence.
So I tried the case where your pod is multi-container. I haven't tried that one, but I tried the one that it has one pod, several containers. And as far as my testing went, it replaced only the first one. So I don't know what happens if you have several pods. Haven't tried that.
Yeah, I'm not sure either. So, yeah.
So,
was that your situation?
I think we run out of time. So if you have any other questions, just I'll be at the Bitnami booth most of the conference. And I know Richard is going to be at the DataWare one most of the conference. So come reach us. Thank you.